Alrighty, we're going to do a little bit of an application today, kind of a cool way to look at modeling real life data with these trig functions that we've been talking about, sine and cosine. So we're going to look at an example today about tides, like height of tides. So thinking about high tide and low tide, being able to make a prediction when there's high tide going to happen, when is low tide going to happen. If you're thinking about anywhere in the coastal regions of the U.S. or around the world, being able to read height of tide for travel and just for safety and all of that is an important thing. So there's lots of places out there. If you Google tide predictor or things like that, there are sites out there that you can find data about this. And what we're going to do is look at it from a trig function perspective. So can we actually model with a real life situation? So I picked out some data from Fairhaven Harbor, which is out east in, I believe it in Fairhaven, that's in New Hampshire, Connecticut. Oh, I should look at that, Google that. But it was out on the East Coast, and I did picked up some data from a website that I'm going to have you guys look at as well for your own set, and I just copied and kind of pasted it onto here, so we would have the data to look at. So this is from starting at the 1st of November, so that was when this first date started, and through into November 3rd. So I had data for a while, and they give some other information too. If you just look at the raw data, they give you a time that it happened, and then they're talking about what's happening at that location. So the only ones I'm really concerned about for writing the equation are for looking at the high and low tides, because those are going to give me the max and min values on my graph. So I'm going to kind of just highlight or underline the ones I'm going to be dealing with. The sunrise and sunset times are kind of cool too, and you can actually do predictions and sine and cosine for that as well. But we're going to look at high and low tide and see what happens for that. So my first job to be able to figure out what kind of model I'm having is I just need to graph it. I need to take a peek and see what the actual picture looks like. So what I'm going to have you do is convert over the raw data into actual ordered pairs that we can graph. So keeping track of the time, so the hours past midnight on this for mine is going to be the 1st of November. Yours might be a different date for when you take your data. So how many hours past midnight, and then what was the height of the tide at that particular time? So some of the data around the world you might see might come in feet. Mine happened to come in meters. So your X is your time and your Y is the height of the tide in meters. So we're going to do hours past midnight starting on the 1st. So at 5:56 in the morning, then that would be 5 hours, almost 6 past midnight. So we're going to need to do some conversion. Since this is just strictly in hours, we need to change minutes into hours. So any of these minutes, kind of the leftover parts, we need to convert to hours. So do you remember how to convert hour or minutes into hours? Well, how many minutes are there in an hour? 60. So I'm going to be taking and I'm going to be dividing by 60 to do that. So if I want to change 56 minutes into hours, I would take 56 divided by 60. Go ahead and do that. And we're going to round to tenths. That's, I think, plenty for what we're going to be doing for our graphs here. So I'm just going to go ahead and round to tenths on that. So it looks like that would be 5.9 for that first high tide. And the height of the tide then was 6.26 meters. That was my first high tide. Okay, so the next one at 12:17, that would be 12 point. If you can go ahead and take your 17 and divide it by 30, or 30, oh my goodness, 60, to get, what is that in minutes? So 12.3 is what it looks like to me, and that would be a low tide of 1.13 meters. Next one, this is kind of interesting. It's military time, so like the 24-hour clock. So 18:23 is like 6 in the evening, so 6:23. But how many hours past midnight is it? Would be 18. And then again, we're going to have to convert over that 23 minutes. So 23 divided by 60. We want to change that over into hours. So go ahead and do that. So 18.4. And then again, that would be high tide at 6.44. All right, now look what happens here. So we get to 11:2. That's the next day. And notice how they're writing the time, 52. So you're just like not even at 1 o'clock in the morning. But how many hours past midnight is that on the 1st? Well, you've done an entire 24 hours plus another 52 minutes. So we're thinking 24 hours total and then another 52. So we need to do hours past midnight on that first day. So it'd be 24, and then go ahead and take the 52 divided by 60. So that would be 24.9, I believe. And that's going to be a low tide at 0.78 meters. Okay, next one, 7 in the morning on that second day. That means it would be 24 plus 7. So 24 plus 7 puts us at 31. And then we got 3 minutes, so it's just barely past 7 o'clock. So 3 divided by 60 would be a 0.1, and that's a 6.29 high tide. All right, so the next one looks like we're at 13:22. So that's like 1 o'clock. So noon would be 12, so 1 o'clock on the second day. So it's 24 plus 13. So we did the whole first day plus another 13 hours, so that'd be 37. And then we've got 22 minutes. So 22 divided by 60 puts you at zero point 0.4, I believe, and that's going to be a low tide of 1.11 meters. Okay, our next high tide looks like it's at 19:30. So that means we're 24 hours for the first day, another 19. So we're looking at it in the evening, and we add those together. That puts us at 43.5 hours, and that's a high tide of 6.44 meters. Okay, then we got low tide happening. Oh, we switched a new day. So now we're on the third, and it's 1:52. So that means we did the entire first day on the first, another complete day, so another 24 hours. So that puts us at 48 total, and then another hour because it's 1:52. So, or 54. So it looks like we're at 49 point, and then 54 minutes. We just need to convert that over. So 54 divided by 60 puts us at 49.9, and that's a low tide of 0.78. So we want to see what this model is. So we've kind of converted this raw data, like real life data, into something that we can graph and take a look at. So what I'm going to have you do next is go ahead and graph this data. So I'm just kind of set up things together. So the x-axis is hours past midnight on that first day, which was the 1st of November. Okay, and then we have y-axis is the height of the tide, or tide height, and that is in meters for me. It might be in feet for you when you do your own data. Okay, so let's see if we can figure out what this graph would look like. We have to figure out a scale. Basically, my numbers for my y's are going to go like basically from 0 up to about 7, not quite 7, and it looks like the x's should go out to about 50. So I'm going to go help and set up a scale that's going to be appropriate for this and plot these points. I'd like you to do that as well. So go ahead and pause the video, and then go ahead and make your graph, and then check back in and see if our graphs look okay. We're just going to plot these points. All right, just going to check back in for kind of the first piece here. I set up my scale, so I'm going to go by 2s on the x-axis. So every 5 would be 10 hours. And then on my vertical axis, I was deciding to do, I went by 2 boxes, but that's for every 1 meter in height. So for example, my first point then that I'm going to graph would be 5.9 hours past midnight. So 2, 4, 6 would be here just a little bit before that, and 6.26. So 6.5 would be halfway there. 6.26 would be about a quarter. So my first point is going to be about there. That's my first high tide. And then I'm going to continue to plot the points. So you guys go ahead and continue to do that. Pause the video, plot the rest of the points, and we'll see what our graph looks like. All right, I have all my points graphed now. So I definitely have high and low tides. If you think about the tide now as a smooth continuous curve, we're looking at something that's do this as best we can here. Sort of this smooth continuous curve. The tide is going up and down and up and down. If you've ever been to the ocean or watched tides coming in, oh my. Smartboard is a little wonky there. If you ever watch these coming in and out, you realize that it cycles along with the phases of the moon. We have high and low tides each day. So now what we want to take a look at is what does this look like? What kind of graph is this? So it definitely is periodic. It cycles. It's starting, my data anyway, at a maximum. Your data might start at a minimum, like a low tide. But let's think about what options we have for in terms of sine or cosine. If I do a sine graph for this, I'd have to know where the middle of the graph is, because for sine, the easiest way to kind of start a cycle is to start in the middle. Well, that would be really challenging to do for this graph because I don't have the middle tide. Like I don't know when it's like exactly in the middle. I know highs and lows. So which function might be easier if I want to start at a high or a low tide? Well, cosine for sure, because cosine, its regular paragraph starts at a maximum. So I think this would be a great candidate for having that sort of a graph. If your data starts at a minimum, you can still do that. It would just be a cosine graph that is reflected, or maybe you could do a different phase shift. So what we're going to try to do is look at this and be able to write the equation of a cosine graph that could model it, because then what we can do is make a prediction. When is that next high tide going to happen, or when is that next low tide going to happen? We'd be able to figure that out by knowing what this graph is as a model, as an equation. All right, so let's talk about what we need to know to write the equation of a sine or cosine. So there are a couple of things that we talked about before. So if you think them through, one thing we need to figure out is what the amplitude of the graph is. So how tall the wave is. Another thing that we have to be able to figure out, sorry about that, get rid of that, is the period. How long is one complete cycle? Is there a phase shift? Has it moved over? Is there a vertical shift? So all of these different things that we've talked about. So if you go back and take a look at this slide here, these are the things we're going to have to figure out, kind of this general form. So I'm picking cosine because it's starting at a maximum, but I need to figure out the amplitude value. It wasn't reflected. I need to know something about the period so I can calculate my k. We know what the traditional period is. It's 2 pi, but we want to figure out what that means for our graph. Is there a phase shift? Is there something that I'm moving over? And then was there a vertical shift? So let's take a peek at our graph again and see if we can do some calculations here. So let's start with amplitude. Amplitude is the height of the graph. So physically on the graph, that means the amplitude distance is the height of the wave from the middle to the top and the middle to the bottom. But I don't really know where the middle is. So think about a way, if you can pause the video too, think about a way you could figure out the amplitude if you know the topmost point and you know the bottom point. How could we figure out the height of that graph? Well, what a lot of people do then to think about amplitude is they take this entire distance of the wave. That would be like 2 amplitudes, right? Because it would be the middle to the top and the middle to the bottom. That would be like 2 amplitudes. So what if I did this whole distance and then divided it by 2 to figure out that amplitude? So instead of having double the height, I just need one of them. So divide it by 2. So if I can figure out a max height and a min height divided by 2, I'm going to have a pretty solid value for amplitude. So I'm going to do a little bit of calculations then on this sheet. So to calculate my amplitude, I'm going to take my maximum height minus the minimum height. So I'm looking at y values there. And then I'm going to take that and divide it by 2. So now we have to make a decision about our data. My maximum height looks like, look at your y values. Maximum height happens a couple times. I'm at 6.44. Now some people average the maximum heights because if we do an average, we can kind of hit all of them. If we're doing a best fit equation, we have to make the determination about what we value. Do we want to do an average of all the values, or do you want to take the true max and the true min? So you're going to have to make a decision. Since my data is pretty close, it's pretty decent, I'm just going to do just the maximum height and then the minimum, which would be at 0.78. But you can definitely, depending on your data, how easy it is to work with, we can make that determination. So I'm going to go ahead and do the 6.44 minus 0.78, and then I'm going to divide that by 2. Go ahead and pause the video, do your calculation. And then let's see what we come up with. Looks like we got I'm going to go out to hundredths here. 2.83 meters would be the height of the wave. And if you think about, if my entire height looks like almost a 7 to 1, the height of the whole wave was about 6, so half of that would be a little bit less than 3. That seems like a reasonable number. Okay, let's talk about period. Period is the length to complete one complete cycle. So I want you to think about that from the perspective of cosine. So if we're starting here and we do a complete cycle, that means we go down to a minimum and we have to get back up to a maximum, and we've completed a cycle. So this distance between 2 maximums would be the length of one complete period. Now we could average that because we're going to have another period here and we'd have another period there. Or you could go min to min, min to min, min to min. That would also be a period. But it's a cycle, basically getting from high tide to low tide and back to high tide again. And we want to think about how long is that? How long does that take? Well, how long is your x values, which is time, right? This is in hours. So we're trying to figure out how long does it take to get from one high tide and then back to high tide again. All right, well, let's see if we can figure that out from our data. Our first high tide is happening at 5.9 hours after midnight. Our next high tide, which is at 6.44, happens at 18.4 hours after midnight. So if we're going to figure out how long that is, like how long is it from about almost 6 hours after midnight to almost 18 hours after midnight, what would you do with those two numbers? Well, you'd subtract them. So we'd go through and we'd see what that value would be. So if I'm going to figure out what that distance is, I'm going to find the distances between the x values. So let's see if we can do that calculation. So for the period, it's the distance, which in this case means the time, right? This is hours past midnight, between 2 consecutive maximums. All right, so 2 consecutive maximums or minimums, right? You could do it either way. So for me, if I go back to those numbers, that means I'm subtracting or looking at x value. So it was 18.4 minus 5.9 puts me at about 12 hours. So it's a little bit over 12 hours. Now think about it. If you've ever been to the ocean, you're going to have a high tide cycle about every 12 hours. So in a day, you like say if you're starting right at midnight, you'd have a high tide at midnight, you'd have one at noon, and then you'd have one at midnight again. So it cycles about every 12 hours. Has to do with a rotation of the Earth and phases of the moon and all that good stuff. But it's always, in most places, right around 12 hours. So the period is 12 and a half hours. Now remember, that's what the period is. That's not what K is. We still need to actually solve for K to be able to figure out what that value is going to be for my function. So if the period is 12 hours, remember what our formula for period is, 2 pi divided by K. That means P, this is P, is 12.5. And I can go ahead and solve for K. So if you remember how to solve for K, go ahead, pause the video, do that, but multiply both sides by K. So then I would have 12.5 times K equals 2 pi. So I'm going to go ahead and solve by taking 2 pi divided by 12.5. And my K value then should be about 0.5. I think it's 0.503 if I'm remembering correctly, but you can double check with that, but I'm thinking that's what it was. So if we're going to go to tenths, it would be about 0.5, but I'm thinking that's what it was for the value. All right, so we have our period. We know how long it takes, and we know what that K value is going to be then. In other words, it's if you think of 12 hours about, 2 pi is about 6 in radians, so 12 in radians. That means we get through 2 complete cycles then if it's normally 2 pi. So, or we'd only get through half a cycle in 6. So we're going to have half of a cycle in that amount of time. So we have our period. We know how long that's going to take. All right, let's talk about the phase shift. So phase shift is how far the graph is shifted from 0. Normally, the cosine graph starts right at 0. So it'd be 0 up at its maximum, but it's not. It's shifted over. The phase shift is physically this distance right here between 0 and when that first maximum is. So if we know where that first point is, we're going to be able to figure out the phase shift. And that, remember, phase shift is an x value, so that would be a time. Let's go back to our data then. What is the shift to that first maximum height? Well, it's 5.9 hours. So the phase shift, don't really have to calculate, we just have to know what we're looking for. If this is the first high tide, how far was the graph shifted over? Well, it didn't happen at midnight, it didn't happen at 0. It happened at 5.9 hours after. So my phase shift would be 5.9, and that would be in hours as well. All right, vertical displacement. Well, that's kind of the old terminology for it. We'll call it vertical shift here. The vertical shift is how far the graph moved up or down if it did at all. Let's look back at our graph. If this graph was not shifted, it means the middle of the graph would be on the x-axis. Well, clearly this is above the x-axis, so we need to figure out how far above it was shifted. So we're thinking about the distance. Where did this x-axis move to? So we want to figure out what that shift was, what that distance was. So think about how we could get to that middle of the graph. So we don't really know the middle because we don't have that data. But do we know how tall the wave is? We do, right? Because that's just the amplitude. So see if we could figure out where this new middle is going to be if we know, and I'm just kind of guesstimating where I think it's going to be. It looks like it's about here, that new middle. So how could I figure out that value? Well, how about if I took the amplitude and added it to that minimum point, right? Because the minimum point shifts me to this minimum, and then plus the amplitude, that would get me there. Or what about if I took the maximum point and then subtracted off the amplitude? Wouldn't that get me to that new middle as well? Because this would be amplitude, right? The height of the wave. So I could do my maximum height minus the amplitude, or I could do my minimum height plus the amplitude, and both of those would get me to the middle of the graph. So it just kind of depends on which way you want to go with that. So you could either do the maximum height, which is your y value, right, minus the amplitude, or you could do your minimum height plus the amplitude, and that will give you that same value. So I can do it either way. So I can do 6.44, that was my max height, minus the amplitude, or I can do my minimum height that I used to calculate that amplitude, plus the amplitude, and either way that gives me 3.61, and that would be in meters. That's a vertical displacement moving up or down. Okay, so what does this give us here? So I'm doing Fairhaven, so you would be doing your data, but I'm doing Fairhaven think it's Connecticut. It's really bothering me now. From the first to the third, I can actually write the equation now. I can come up with what this whole equation is by putting all these values together. So y equals my amplitude, 2.83. I know it's not reflected because it started at a maximum. Cosine of my k value was zero point 0.5, and I'm pretty sure it's 0.503, but I'll just put zero point 0.5 for now just because I'm not 100% positive on that. And then I need a value, so for my variable, which I said was x, that's hours past midnight, minus the phase shift, which was 5.9 hours, and then plus the vertical shift 3.61. All right, so I have my equation. Now, if I want to do a prediction, I can use that model and I can help it predict. I want to show the graphing calculator part of this as well, so we can see actually how this is, how this actually matches up and works with those values. But let's take a look at how you'd find your prediction. So we'd want to do for 12 hours past your last high or low tide. So I'm going to go ahead and take a look. My last thing that I had was a low tide, right? So this was a low tide value. So if I want to figure out 12 hours past, and the reason I picked 12 is because that would get me about the length of the period. So it should be to approximately my next either max or min, was at 49.9 hours. That was my last max or min value. So I want you to predict what would 12 hours past that be. So that's the value that I'm looking for, and what kind of number should it be. So 12 hours past, that would be 49.9 plus 12. So that would put me at 61.9. So if I want to figure out what the value of the function is at hour 61.9, we can figure out by substituting it into the equation. All right, so let's go back to our equation here. So that would be an x value of, we did 49.9 plus 12, so 61.9, which would be on the third still, I believe, right? Because that would be 48 hours plus another 12, so it'd be at 1354. Right, because if our last value was at, let's go back to the raw data here, at 154, I just add 12 hours to that. So on that third day, add 12, so it'd be 1354. So a little past noon on the third day, what would the height of our tide be? Well, do my calculation. So I'm going to substitute in that value. So 2.83 times the cosine of 0.5. My x value then is the 61.9 minus 5.9, and then plus our vertical shift. And go ahead and type that in your calculator. Pause if you need to. And the height that I came up with was 0.89 meters, which is pretty close to a low tide measurement. So when I'm thinking about low tide, it should be, because if I'm doing it in a complete period, I would be finding 12 hours after I would be finding my next low tide. If I wanted to find a high tide, I should only be going about 6 hours after, because remember the complete period was about 12. So I'm predicting when that next low tide would be. Okay, so I want to check the graphing calculator part of this and just see how accurate we are. So we made a prediction about what we think is going to be happening based off our equation. This is the power of this. We can now project any time in the future, so any date, any time, what that tide is going to be. So what I'm going to have you do is go ahead and enter in your data in your stat menu. X is in list 1, Y is in list 2. Okay, so we're going to do that. So I have to get my new data put in there. So I'm going to do that. And then we're going to put our equation in the Y equals menu. So I'm going to do that as well. And then we're going to turn on our stat plot and see if this looks like it's supposed to. So I'm going to go ahead and put my data in. So data in your stat menu, X's and Y's, equation in there. Make sure you're in radian mode. We're not in degrees. We're doing just regular values. And then let's see if that works out to what it's supposed to be. Let's see if our model fits. So go ahead, pause the video. Okay, so where I'm at is I put my equation into my y equals, so I have that in there. In my stat menu, I put my x's in list 1 and my y's in list 2. For stat plot, since we're going to be plotting, we want to look what this looks like, you need to turn your plot 1 on. So go ahead and turn your plot 1 on, and it's just a scatter plot, which is great. That's the default. X's are in list 1, y's are in list 2. We could go and set up our regular window, and I'm just going to do that quick. So 0 to 50 is what we did for x's, right? And then I went up by, let's see, we went up by 2's. And then for y's, I went from 0 to 7. and then I went up by 1. So you could also do a stat fit or zoom stat, which would also work. So let's take a look at the graph and see how we did. So we have our data points, we have our model. Look at how cool that is, you guys. It actually models the heights of that tide that we did. So if I wanted to go to my projection, I was going to look at 12 hours past. Let's go to our table once, our table set. We wanted to do, what was it, 61, 62 hours. So I'm going to start my table at 62 hours past midnight, and let's see how close our projection was. 0.85, pretty darn close. And I guess we're a little bit off because it's 61.9. But you can see the height of the tide at any point in the future. This is a function of tide height as a function of time. So it's a really cool way to see how these model together. So this is what I wanted you to be able to understand, is that we can take real life data, watch and see what the model is, write that equation from what we know, and be able to do those predictions. So this is kind of a great example of modeling with a trig function.